Aside from a little bit of thermodynamics, this is like the beginning of all like the new stuff. For the rest of your life in here, everything's going to be new, except for a little bit of electron configuration like one day. So when we learn something new, today is just about like getting it down on paper, getting a basic understanding of it. This unit has three major parts to it. The first part is so much calculator button pushing. And you have to have a graphing calculator. We will be stat plotting and graphing things. So either get one or borrow one every day, but we will be building stat plots and getting the equation of the line for them. The second part is on reaction mechanisms. We've kind of talked about them a little bit before, but it's not like mathy. And the last part is a lot of biology. It's about catalysts. And I think that if you took AP Bio, or maybe you remember from bio what that has to do with. But this first part is that. Okay, and that is just basically, you know how in math, like you're always like finding the equation for the line, like find the equation for the line, like in 17 different ways. We're going to be basically doing that. We're going to be finding the equation of a line of a graph of concentration versus time. The problem is it's not linear, which means we're finding the equation of a point on a curve on the line, which is called calculus. And so what we'll be doing, yes, if you've taken calc, or if you're in calc, it's just going to kind of form in your head a little bit faster. We're basically integrating a curve to get the equation for the point on the line. But the whole unit is called kinetics. Kinetics is the chemistry of a rate of a reaction. Rate means how fast it's going. Some reactions are super fast, like we mix them and then there's lots of bubbling and things are happening. Some reactions are super slow. Our unit for rate is going to be in concentration versus time. So how does the concentration change? Concentration change over time. Okay, is basically what we're going to be doing. Change in concentration over change in time would be a calc concept, but I'm going to be doing it all for you. Basically, you're just pushing a lot of buttons. Okay. So there's a lot of different ways rates can change over time. The first way, if that matters, is called the state of the reactant. So that's either if it's a solid, liquid, gas, or aqueous. That's what state means. Some are faster, some are slower. New symbol, which you might have just picked up on, concentration means molarity. And molarity means I can put it in brackets. Molarity we did in our solutions unit, it's moles per liter. So how much stuff is in the volume? Temperature is the same thing as kinetic energy. We learned that already. That can change a rate. And then catalyst is this big bio concept that we're going to do a whole section on at the end. Okay? So how do I make things faster? The more that things collide, the faster they're going to react. So if I have pretend element A reacts with pretend element B, and then it turns into pretend C plus D. Those aren't elements. I know C is carbon, but that's not what I do. We call these reactants, and we call these products. The reactants are turning into the products. Not like magic, but like by rearranging their bonds and stuff. Our reactants are going to disappear over time because they're turning into the products. So our products are going to appear over time. So that means the concentration of my reactants is going to go down over time. They're turning into my product. Molecules must collide in order to react. I can't make C a D if A doesn't run into B. Like, they have to physically run into each other. So the more they collide, the faster they're going to react. We call that rate. When the music starts to talk about things disappearing, things appearing, and how come if I collide more, my rate is going to be faster. Ready? Go. Homogeneous means that they're in the same state. Like everything is a solid, everything is aqueous. They're typically faster. Heterogeneous is going to be faster as long as the surface area is increased. We're going to draw a picture. We're going to draw two boxes. Surface area just means like how much of it can it actually react with. So on the left, we're going to have like a big chunk of something. I'm going to label it solid. If I took that with, like, smashed it with a hammer and I increased its surface area, and now I've bunched it into a gazillion little pieces, I increase my surface area. So instead of the collisions only being able to happen on this outside, because it's not magic, you can't get on the inside, the reaction can only happen on this outside. But if I break it into a gazillion little pieces, now my reaction, my collisions, can happen all over the place. That makes it faster. More collisions is faster. Increase surface area increases collisions equals faster rate. Because they smashed it. That's how come they don't give your Kool-Aid in like a big chunk. It would take forever for it to dissolve. The little water molecules are only going to hit the outside. It's like fine powder. Okay? Also, if I increase my concentration, that means I have more stuff. More stuff means more collisions. More collisions means faster rate. If it's really dilute, there's not that much stuff for it to react with. Temperature means kinetic energy. If I have a higher temperature, I have more kinetic energy. More kinetic energy means more collisions. They're moving faster. Hot stuff reacts faster than slow stuff. And a catalyst works by, we're going to write this and we're going to talk about it a bunch. I think if you took EP Bio, you already know this. It works by lowering the activation energy. Which today we're just going to write down and we'll revisit later. Some new symbols. I think you know triangle means change. Brackets I told you means concentration. Concentration means molarity. Molarity means moles per liter. Lowercase t is going to be our time. Doesn't have to be in seconds, but it's probably in seconds or minutes. Sometimes if they're really slow reaction, it could be in hours. Most likely it'll be in seconds. And rate is going to be in molarity per second. How does my concentration over time change? Which is the same thing as a slope of a line. The problem is it's not linear. But if you think about it like this, that if I had a data table and my change in time, so this is every 50 seconds. And this is what's happening to my concentration. It should be going down, right? It's turning into this stuff. Here, my concentration is going down. Basically, I'm just taking my slope, my y2 minus y1 over x2 minus x1 to get the rate. Just my change in concentration over change in time. We can do it a few different ways. We can take the average, or we can take it instantaneous. So find this and just redraw this graph. Our x-axis is always going to be time. Our y-axis is always going to be concentration. Let's do our pretend A plus B yields C plus D. And we'll put A on our y-axis. So at time 0, I have a lot of A. Nothing has happened yet. Look at all this stuff. Remember, A and B are colliding and they're turning into C and D. So as time goes on, my A is disappearing, 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 colliding, colliding. Oh no, harder to find a B to run into because there's less and less and less of them. It's really hard to find a B. I can barely find a B, so it's slowing down. So it's not linear. It's going to have a curve to it, and that's because it's really hard for A to even find a B after a while. So our rate slows down. My slope changes. This is where calc comes in because I need to know what is my slope at this exact moment. Okay? Take a second and just talk about why is my graph curved? Why is it not linear? Ready, go. The rate slows down over time. That's where we get the curve from. The game we're going to be playing with math this entire time is to find the equation for the line. It's called a rate law. And we're going to practice it in sample problems. You have to turn to like the back of your packet. And it should look something like this. Grab a calculator if you need a calculator. You don't need a graphing calculator today, but you will starting Wednesday. You just need a button pusher today. So the first relationship we're going to talk about is if I change the concentration, what happens to my rate? So if I put less stuff in there and I lower my concentration, I would expect my rate to go down and be slower. If there's less stuff, it's really hard for A to find B to even begin with, so it's going to be slower. If I increase my concentration, I have lots of them. In my brain eyeballs, I see them as like red and blue balls, like red and blue dots. And so if I have lots and lots of red and blue dots, they're going to collide very easily and make lots of purple dots. But if I only have a few red and a few blue, they're going to be bouncing all over the place. The chance of them colliding is going to be different. The differential rate law is the relationship between the concentration and the rate. We're going to do something called the integrated, that's an S, we need molarity per second. We'll do something called the integrated rate law, which is a little different. A rate law is the same thing as a math equation. A law in chemistry and science is an explanation for what is going to happen. This is the equation for the line. It's very similar to y equals mx plus b. It's very similar to doing like point slope form. Like it's all the same thing, but it's the chemistry version, and it's called rate law. It's rate, which is in molarity per second, equals a lowercase k, which is a constant, similar to slope that you're going to have to solve for every time because every line has a different slope, times the concentration of that reactant A to the m monkey power. That's called a rate order, times the concentration of the other reactant B to the n narwhal rate order. The rate order just says what the exponent is to give it its right curve. Okay? These are in molarity. That's capital M for molarity. Molarity is moles per liter. It's concentration. This was called the rate law constant, which is the same thing as a slope, but in chemistry words, rate law constant. And monkey and narwhal are called the rate orders. We're going to learn it by doing it. So can you just flip the page? Show you what it looks like. So in math, you know, when you're given a graph and it's like, find the equation for the line, y equals mx plus b, and you have to like solve for the slope and you do the stuff and using the points, that's what we're doing, okay? It's called the initial rate method because we have initial concentrations and initial rates. Initial just means time equals 0, which is like an asymptote. We actually can't take data at exactly time equals 0, but as close to it as we can, okay? They're going to be data tables that have different trials. So for the first trial, these are meta-ionics. Don't get scared because they're charges. They just took out the spectators. They will do that on the entire AP exam. Spectators are never there. Okay? So it was probably like potassium or something. But the first time they had a concentration of 0.1 for the NH4 and a 0.005, and this was the slope. That was the rate. And then they kept this the same, but they doubled the NO2, and look at the rate double. It got twice as fast when my blue dots got twice as many. And then the third time, they doubled the red dots, kept the blue dots the same, and my rate still doubled, okay? So there's always going to be a constant and then a variable. A constant just means it doesn't change. It's like keeping the amount of water to water the plant the exact same. So you know it doesn't have anything to do with the water. It has to do with the sunlight. Okay? To write the basic rate law, what we're going to do is just that rate equation. Rate equals K, slope we have to solve for. We're going to actually plug in the stuff though. So instead of A, we're going to call it NH4+. I just pulled it off the chart. To the monkey, which we haven't solved for yet, times NO2 minus to the narwhal, which we haven't solved for yet. And now we're just going to use all the data to solve for each of the things. Okay? I'm going to teach you a logic way to solve for monkey and narwhal, but you could also math it if the logic part is too hard. It's just easier to teach it that way because I think if I only teach you the math way, then you're going to think you have to math it every time. To solve for monkey, I need to see if when I change the NH4, what happens to the rate. So I'm going to do NH4+, that's my monkey, and then my NO2 minus, that is my narwhal. So if I look at trial 1 and trial 2, my monkey, my NH4 plus doesn't change. If I look here at 2 and 3, my narwhal doesn't change. So if I'm trying to see how changing my NH4 changes my rate, I'm going to have to look at this. Because look, I doubled my concentration. It went from 0.1 to 0.2. That's called doubling. 2. To the monkey equals what happened to my rate. 2.7 to 5.4 is also double. This was my concentration. This was my rate. I doubled my concentration, did not change this one, it's a constant, and my rate got twice as fast. So that's a relationship of 2 to the monkey equals 2, so monkey, my exponent must be 1. There's so many things to talk about. Mainly talk about how come I need to make sure that my narwhal does not change when I'm solving for this. Where did this 2 come from? Where did this 2 come from? How come I need to make sure narwhal doesn't change? Ready? Go. Okay, can you do narwhal now? So looking for narwhal means that I'm looking for where it changed, but I got to make sure monkey doesn't change. I need a constant. I can't change the amount of water and the sunlight to see what happens to the plant. I can only change one at a time. So I doubled my concentration. I got to solve for narwhal. What happened to my rate in those 2 trials? 1.35 to 2.7 is also double. So narwhal equals 1. It's either going to be 0, 1, or 2. Okay? 0, 1, or 2. So even if it looks kind of scary with exponents, like it will work out to be a 0, a 1, or a 2 for your monkey narwhal. Okay, so now we've solved for this. We now know that monkey is 1 and narwhal is 1. Our next step is we can solve for k. We can solve for the slope. So I'm going to plug in trial 1. Does it matter what trial to plug in? Not really, but we won't all get the exact same answer unless we plug in the exact same trial. Okay, so if you want to match my answers, then plug in trial 1. So my equation says rate equals. So in trial 1, I'm just pulling off reading headings off the chart. My rate is 1.35 times 10 to the negative 7. Equals lowercase k I'm solving for. Times the concentration of NH4, pulling off the chart, reading the headings, 0.1. I know monkey is 1 times the concentration of narwhal. Is it 0.005? I didn't actually look. Okay. And I know that narwhal is 1. And then it's just down to button pushing and a little bit of algebra. Okay? Solve for k. We're solving for m right now and y equals mx plus b. You get 2.7 times 10 to the negative 4. Okay, that's only half the credit though. Getting the number is 1 point. You get a whole nother point if you do the unit right. Okay, so I'm going to switch to red, just kind of show that it's 2 separate things. This is a point. Now you got to find the unit for a second point. So what we're doing is we took rate, which is molarity per second. Concentration was molarity. And we divided both sides, right? So I took my rate and I divided by molarity to the first power because monkey was 1. and molarity to the first power because narwhal was 1. So I'm just like taking out the numbers and doing letters only. Top matches cancel bottom matches. So M on the top, even though it's on the top, it doesn't matter. On any top is going to cancel any bottom. So 1M cancels 1M. So what am I left with? I'm left with the seconds on the bottom. Bring to the top, the exponent turns negative. Remember that game? When things come off the bottom and you bring them to the top, they become negative. And that's a point. You get a point for the math and a point for the letters. Okay, so please talk about that. How did I get S to the -1, M to the -1? Okay, what is the rate when NH4 equals 0.3 and NO2 equals 0.1? Sorry. So rate equals K. We now know that K is 2.7 times 10 to the -4. Times the concentration of NH4 to the monkey times the concentration of NO2, which I didn't type in for whatever reason, to the narwhal. Button pushing. Unit for rate never changes. It's always molarity per second. Only the K1 do you have to solve for every time, okay? Overall reaction order is monkey plus narwhal. This is a point, kindergarten math. Monkey plus narwhal is 1 + 1 = 2. It's like preschool math, I think. So take it when you can get a point for doing preschool math because there's so many hard things that it's easy. And just one more thing. Rate of appearance, rate of disappearance is the whole ratio. Remember the products, the C and D are appearing, the reactants, the A and the B are disappearing because they're turning into the products. So it says hydrogen disappears at a rate of 3 molar per second. What is the disappearance rate of N2? It's really this simple. Always start with what you know over 1 times an line. Just do your mole ratio, unknown over known. I'm left with molarity per second. Disappearance just means that it's a reactant. But I could also ask, what is the rate of appearance? So now this is my question mark. Same game though, just do a mole ratio. Unknown over known. 3 times 2 is 6, divided by 3. Okay, there is a white worksheet packet. Can you please pull it out of your file? It's this chapter 14 worksheet. Tonight is one of those non-negotiable homework days. A lot of times it doesn't matter to me whether you're doing it or not because I think you do it regardless. I know that you could do this right now because you are following me, but these are all new words. These are all new things. So you have to practice it tonight. Otherwise, you won't be able to do what I'm asking you to do tomorrow, and that will lead into not being able to do what we're doing the next day, and then you're going to get frustrated, and I'm going to get frustrated, so you need to do this. All I'm asking you to do is 1 through 3. It's just 2 more times through. Plugging in, solving for K, finding monkey, finding narwhal. 1, 2, and 3. And then tomorrow, you are not working on quiz corrections or test review. You're doing this, kinetics 1 and 2. Okay? I'm going to be mad and hopefully learning something good to help you do better on your